This problem is to change the order of integration and to evaluate integral from 0 to a, y to a, x by x square plus y square dx dy. We will quickly recap the 4 points which we need to observe when we have the problems on change of order of integration. The first one is to check the given problem for the right order. If that is going to be right, we can proceed as such. If not, then you will have to change the direction of it and then you will have to restate the problem. The second one is going to be the identify the region and you will have to sketch it. So sketching the region is going to be the second point. The third one is going to be the fixing of new limits. So once this is done, then fixing of new limits with respect to the change direction, and 4, we evaluate the problem to the given order. So this is how the process goes. Now to check if the direction is going to be in the right way for the given problem, we notice that we have the limit y and a. So y has to be the limit of the variable x, because x cannot take the limit x itself. So it is going to be the variable y, then it has to be the limit of the variable x. So x varies from y to x varies to a. So y to a. So x varies from y to a. So x comes first, so dx has to come first. So the given problem, they have already given it as dx. So the given order for which the evaluation has to take place is going to be right. And the fixed or the constant limit are going to be for the y variable which follows next. So this is going to be right. So step 1 is done. Second one is identifying the region. So what are the region to be covered is x equal to y, x equal to a, y equal to 0 and y equal to a. A caution over here, you will have to use 2 different colors to distinguish between the axis and then your region, so that there is going to be no confusion when you are going to plot the limits for. So the given equation is plotted for the axis so we take the axis in one color, and now we move on to the other quantities. So this is going to be our direction of your x and this your direction of your y. So we move from the lines y equal to 0, y equal to a, x equal to a first to plot them, as they are very easy to plot for first. Y equal to 0. What does y equal to 0 represents? This y equal to 0 represents your x-axis. So first we will plot our x-axis in the next color. So the next color is x. So this is going to be the line y equal to 0. The next one is y equal to a. How is the line y equal to a? It is going to be just a line parallel to your x-axis in the same direction what we have drawn now. So say suppose this is our line y equal to a. So we are done. The third one, x equal to a. So how much ever distance we have moved over here, the same distance we move over here to fix the line called as y equal to a. So we have the line y equal to a. So now this gives me your x equal to a. So this is your line x equal to 0, your y-axis, and this the line x equal to a. So we have plotted the 3 lines y equal to 0, y equal to a, x equal to a. Now how about the line x equal to y? How to get it? So for tracing the line x equal to y, substitute the values of y over here in the other equation. When y happens to be equal to 0, then x also happens to be equal to 0. So the coordinates x comma y is 0 comma 0. When y happens to be equal to a, on substituting back, x also gives you a. So the point x comma y is a comma a. So the line x equal to y passes through the point 0 comma 0 and a comma a. Now this point is the origin 0 comma 0. This point is your y equal to a, so x equal to 0 and a. This is the point of intersection of x equal to a and y equal to a, so it is a comma a, and this point is intersection of a and 0, so it is a comma 0. So we have the line to pass through 0 comma 0, which is this point, and a comma a, which is this point. So now draw your line passing through these 2 points in this way. So this is going to be our line which is given by the name x equal to y. So this is our x equal to y. Now going for the region which we'll have to integrate for, we check whether the region is going to be closed. Over here it is going to be open. Here it is open. Here it is open, open, open. Here when you are drawing it in the same color, then you will have an ambiguity whether to choose this or not. This is the axis which is an imaginary line, so this is going to be also open. So the bounded region is the one which is going to be the one over here. So this is my enclosed region which is now to be evaluated for. So I am done with my region. So the second point is also over. So moving on to the third point. What does our third point say? Third point is fixing the limit. How to fix the limit? Now, given problem is in the direction of which? So direction of x. So when we change it to the direction of y. So how to get the direction of y? Draw a strip parallel to your y-axis. And what is the direction of y? Direction of y is from bottom to top. So which is the bottom part for us? The bottom part for us is y equal to 0. So we now cover this shaded region by drawing strips parallel to your y-axis. So this is how we do it. So we are drawing a strip parallel to your y-axis. So moving from bottom to the top. We now fix the limits. So the limits are fixed as, so bottom limit. What is the bottom limit? Y is starting from 0. It moves up and then it goes up and reaches the point here. What is this point? Y equal to x. So y varies from 0 to x. Y equal to x. So the limits of y are now fixed. Now getting for the limit of x. This is a variable limit. So x will now take a constant limit. So what is the total variation of x? Here to here. So this is the total variation of x. So now look into the x coordinate. Where is your x coordinate moving? In the direction of x from 0 to a. So x varies between 0 to a. So the changed limits are, or the new limits are 0 to a, 0 to x. You can notice that they are not the same as got by replacing the variable x by y. So please don't do that mistake of just replacing your x by y if they have asked you to change. So fix the limit and change it accordingly. So haven't got the new limits, the last task is to evaluate the problem. So we move on to evaluate integral from 0 to a, evaluate integral from 0 to x, 0 to x. So this is my y, this is my x. The function will never change. The function will always be the same as given in the question. The given question is x by x square plus y square. X by x square plus y square. So what is the new order for us? In the direction of y. So dy comes first, then followed by it dx. So this is the quantity. When I am going to integrate with respect to y, the role of x is treat your x to be constant temporarily. With respect to y, you treat your x as constant temporarily. So what we have is just 1 divided by x is a constant, so I can ignore it. Something of the format a square plus x square dx. So I'll have to integrate 1 divided by a square plus x square dx. And we know the formula for this to be equal to 1 by a tan inverse of x by a. So integral dx by a square plus x square is 1 by a tan inverse x by a. Now the variable is y over here and the constant is x over here. So wherever you have a in the formula, replace your formulas a with x, and wherever you have x in your formula, replace it with y. So what will happen? X is already present, a constant which we did not disturb. So now replacing X, wherever we have A in the formula, we are replacing it with X. So this becomes 1 divided by A. 1 divided by A. Wherever we replace it with X. 1 by X. Tan inverse of, wherever we have X, we replace it with Y. So y divided by the constant. What is our constant here? Constant is X. So this is the function which we get after integration between the limits 0 to X. Now we have to apply the limit, and still we have the bending value for X between 0 to A to be evaluated. Now applying the upper limit minus lower limit, this X can be very well cancelled off. So we have tan inverse of, now we are integrated with respect to y, so y takes the value upper limit minus the lower limit. So y will be replaced as x by x minus tan inverse of 0 to be integrated between 0 to a, finally with respect to dx. We know that this gives me tan inverse of 1. When does tan reach the value 1? Tan 45 degrees is going to be equal to 1. So what is 45 degrees in terms of angles? So this is going to be pi by 4. So when does tan inverse of 1? Tan inverse of 1 is pi by 4. So this gives us pi by 4 minus, and when does tan reach 0? Tan reaches 0 at the value 0. So this is pi by 4 minus 0, which has to be integrated between 0 to a dx. Now this is a mere constant and it doesn't affect your integration by any way. So you take this pi by 4 common outside, and dx on integration gives you x between the limits 0 to a. So the final answer is pi. Upper limit for x takes a and lower limit for 0, pi a by 4. So after we change the order and evaluate, the final answer is pi a by 4.